Okay. Just two sections here, 5.4 and 5.5. It's really dealing with integrals and the application of the fundamental theorem of calculus. We could probably spend a whole month just looking at this kind of material. We don't have that amount of time, so we try to divide up as best we can according to the book, and the AP exam, things like that. We start with the definite integral and the indefinite integral. Part of this will be very, very much review for you guys. Do you know the difference between a definite article and an indefinite article? We see a definite integral. Definite integral is this: a to b of f of x dx is equal to. This is the most important thing I taught you from last unit. Let's see if you remember it. That's it. That's the definite integral. It comes out with a definite answer. Whereas the indefinite integral, we don't have bounds. The integral f of x dx. It's a fancy way of saying an antiderivative. And so we find f, big F of x, but the deal is we add a plus c onto the end of it. C refers to a constant. Why? Because if I ask you, what is the antiderivative of 2x dx, you tell me, what is the antiderivative of 2x dx? 2x squared over 2, which is just x squared, but it could be x squared plus 5 as well, right? So because there could be any constant on the end, we write x squared plus c. X squared plus c. That would be an indefinite integral. And so we begin by actually showing you how to check your answers. If I, don't write this down, have 2x plus 4 is equal to 10, and I want to solve that, you come up with an answer of 3. Everybody agreed? How do I check my answer? I plug it back in. If you have the integral, if you have the integral of x 2x dx, and you come up with x squared plus c, you can check to make sure it's right. How? You take the derivative of this, and you should come up with that. Well, what's the derivative of x squared? 2x. What's the derivative of a constant? So I got that, so I know that it is correct. So you can verify they are inverse operations. Everybody clear? That's all we are learning today. Let us show how we apply that to different problems. The integral of negative x sine of x dx is equal to x cosine of x minus sine of x plus c. It's saying that the antiderivative of this, which by the way you don't know how to find yet, that's very complicated. The antiderivative of this guy happens to be equal to this guy. I'm going to verify that's true. How? By taking the derivative of that. Let's see if you remember how to take derivatives. It's been a little while. How do I do the derivative of x cosine of x? Product rule, thank you. What is the derivative of x? 1 times cosine of x plus, what's the derivative of cosine of x? Negative sine of x times x. So I just did that part right there, right? Product rule, ready to go. Minus sine of x. What's the derivative of negative sine? Negative cosine of x. And what is the derivative of a constant? Nothing. So look at what you have here. We have cosine of x plus negative sine of x times x minus cosine of x. What happens? Cosines cancel, leaving me with negative x sine of x. Is that what I have after the integral? So therefore, I verified that that differentiation formula is correct, or that integration formula is correct. Yeah. Try next one. I want to show that the integral of that gives us that. Oh boy. So what do? I take the derivative of what's on the right-hand side, and I should get the left-hand side. So I have 2 over 3a, and I'm going to write it using a rational exponent. I don't like the root thing, so I'm going to go ax plus b raised to what power? 3/2, thank you, plus c. I'm going to take the derivative of that. Now, because it says dx, x is the variable, all the other things are constants. So therefore, this 2/3a is simply a constant. Anybody know what rule I use to take the derivative of that? I do use the chain rule, most beautiful rule in calculus. We have 2/3a times u to the 3/2. What is u? Ax plus b. Let's take the derivative of ax plus b. Derivative of ax plus b, a. If you get confused by it, just put a number. Put it, say 3x plus 7. What's the derivative of 3x plus 7? 3. So you can see. So if you ever struggle, just model it with an easier problem. Model with an easier problem. Excellent. Relevant mathematics. And then if I want to take this derivative, I dump down the 3/2. What happens when you dump down the 3/2? Yeah, you just get 1/a, right? Times u to the 1/2. Now we're going to multiply those together. A times 1/a gives me 1. So I just have u to the 1/2 that is left. What is u? Square root of ax plus b I have. Is that what I wanted to come up with? Yeah, it is. It's right here. So we got that. So the dx, that tells us our variable. Our variable is x. So it's saying if you had any a value or b value, so any a value or b value, those are going to be constants. Okay, so be constants. Question? Yep. So now let's go back to Rachel's question. Here we use the product rule. Here we use the chain rule. Will we learn the reverse chain rule? Yes. It's easy. You're going to learn it during this unit, and it'll be what the majority of your test is on. How do we go from there to there? We'll make that look easy in about a week. So if you had a y variable. Okay. We'll go through a couple problems today. We'll give you some time to work, and we'll go from there. Tomorrow we'll be completing the rest of the notes. It says find the general indefinite integral. So just like you practice finding derivatives during first semester, you're practice finding antiderivatives right now. Indefinite integral x to the negative 3/7. What's the antiderivative? Yep, x to the 4/7 over 4/7 plus a constant. If you forget the plus a constant, I mark it every time on the test. Okay, have to have the plus constant. I divide by 4/7. I have 7/4 x to the 4/7 plus a constant. That is the general indefinite integral. We don't know how to do the reverse product rule yet. So what should we do for letter B? Yep, so I have the integral of 2x minus 6x squared plus 2x to the 6th dx. Now that it's written as a power, I can go ahead and find the antiderivative. What is the antiderivative of 2x? X squared. What's the derivative of antiderivative of 6x squared? 2x cubed. What's the antiderivative of 2x to the 6th? 2x to the 7th over 7. Am I done? Plus a constant, otherwise it's wrong. How about letter C? What should we do? Yep, and I get 2 minus or plus. See, I have a negative 2g and a positive 3g. That makes plus g. then minus 3g squared dg. Antiderivative of 2g, very good, plus antiderivative of g over 2, antiderivative of 3g squared. G cubed plus a constant. Oh no, what about d? Is it positive 2 cosine or negative 2 cosine? I'm not finding agreement. It is negative. So, and once I write it down, I check it. What is the derivative of, what's the derivative of negative 2 cosine? Positive 2 sine. Because remember, with cosine, you have to attach a negative, right? So it's when you check it that you sometimes figure out, did I do it right or wrong? Antiderivative of 4 cosine? 4 sine. It's constant. We will simply do these 2 more, and then we'll move on from there. Please look at the very, 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 very back of your notes. You have a various calculus notes sheet. There are a couple formulas that I expect you to remember from trigonometry. Can we all agree that you should be able to remember sine squared of x plus cosine squared of x is equal to 1? And if you look in the middle of your sheet, you see that I have laid those out for you right here. So I know that they're not all easy. I think we encountered this not too long ago where you guys were asking antiderivative, secant squared, and things like that. They are all right here. In fact, I also have a list of all of your antiderivatives over here for you. So I have taken the time to organize that for you so you don't have to make the notes on your own. But after that, it really becomes incumbent upon you to remember them. And I know you're great at memorizing things for all sorts of your other classes. You sure can do it for this class. So the Pythagorean identities, can we all agree that you have to remember that one? I'm also going to say that this one is fair game. 1 plus tangent squared is equal to secant squared. I won't use the 1 plus cotangent squared. Okay? Fair enough? Okay. These are all your double angle formulas. I won't use those. But I will use that one. So there's really 3 trig formulas other than, like sine is, or a tangent is sine divided by cosine. I mean, I think that's obvious as well. But sine of 2 u is the same as 2 sine of u cosine of u. So double angle formulas, things like that. Okay? So I think that those are pretty straightforward that we have to be able to use those. Okay. Now, if I flip back to where I was, notice the challenge here. 3 over sine squared of x minus 1. The fact is that is a very challenging integral. You can take any function and finding the derivative is a piece of cake. But all of a sudden, I give you an integral, super, super challenging, unless you see the substitution. Instead of sine squared minus 1, what can I put in its place? Close. Notice, if I want to make that look like that, I would subtract 1 from both sides. I would have a sine squared of x minus 1, and I would subtract a cosine squared from both sides. So Riker was correct. We said cosine squared. We just want it negative. So this becomes the integral of 3 over negative cosine squared of x dx. Still looks complicated. I wish I knew what 1 over cosine was. Secant. So you have the integral of negative 3 secant squared of x dx. If only there was something we took the derivative of to get secant squared. Tangent. The derivative tangent is secant squared. Negative 3 tangent of x plus c. That is the integral. So we had to know a derivative. We had to know a substitution. Made it a little bit easier. This one, some people see the sine divided by cosine. They want to plug in tangent. But the fact is, you don't know the antiderivative of tangent either, do you? I mean, think about it. Is there something we take the derivative of to get tangent? That becomes kind of complicated. By the end of this unit, we'll be able to figure it out, but that's involved. I wish that there was something we could plug in for sine of 2x. It's 2 sine of x cosine of x. What happens? Cosines cancel, and I'm left with the integral of 6 sine of x dx. I wish I knew the antiderivative of 6 sine of x. What is it? Sometimes people get frustrated during this unit and they say, well, I don't know what to do when. That is a very normal feeling. I wish I could tell you exactly what to do when. It's like solving a puzzle. Sometimes you have to try things and see where they fit. And sometimes it takes longer than others. The fact is that you can try to use your resources and try to rewrite it, but sometimes you might end up down the wrong path. You might have to try something else. It really is a measure of what you remember and hopefully seeing enough examples. I'll try to show you plenty. Tomorrow we'll pick up here, just a reminder of the Fundamental Theorem of Calculus Part 2. I will hand you your worksheet so you can at least get started on that. Shania, we can't wait to see you again.